Calc. Here's the exam 1 review, number 7. So we've got a whole slew of limits here, and so we're going to start at the top with a tangent, everybody's favorite. So we can split this into two separate parts. So we got the limit as x goes to pi over 2 from the positive side, and I'm going to pull the 4 out here. Tangent of x plus the limit as x goes to pi over 2 from the positive side of 2x. The second one's pretty straightforward. I can direct substitute pi over 2 in, and I get pi. The first part, though, you have to think about what that graph of tangent looks like. And just real quick, here's my picture. We know tangent hits 0 at 0. It's got an asymptote at pi over 2 and negative pi over 2, and it goes this way. Okay, now we want to approach this right side asymptote from the right, which means that this is heading down off towards negative infinity. So I have a negative infinity plus pi. The pi doesn't matter. So the limit as x approaches pi over 2 from the positive side of 4 tangent x plus 2x is negative infinity. Yay, start with an AQ1. So the second, B, got the limit as x goes to infinity of e to the negative 3x plus 12 over x to the third. So let's take a look at this in part. E to the negative 3x, e to a negative number. So off to the left-hand side, our exponential is approaching 0. 12 over something getting really, really big is getting closer and closer to 0. So our limit here is 0. See, I've got x now is approaching negative infinity of e to the negative 3x. That makes that e to the 3x part positive. That is growing without bound. Second part is still 0. We get a limit of infinity. D, we have got a limit as x approaches infinity. So we are going to focus on just the highest powers. Limit as x approaches infinity. What do I have? Negative 5 x to the 6th over x to the 8th. I can reduce. Limit as x goes to infinity of negative 5 over x squared. As x gets really, really big, I've got negative 5 divided by something really, really big. This is going to 0. E, I got the limit. Here we're going to spread this into two parts. As x approaches infinity of the natural log of x plus the limit as x approaches infinity of 15. Even if it's growing slowly, as x grows without bound, the natural log of x is also going to grow without bound. So we've got infinity plus 15. I get a limit here of infinity. Okay. F, I am looking at the limit as x approaches 2 from below. X squared minus 9 over x squared minus 4. I can factor numerator and denominator, but we cannot cancel anything, so we are going to have an asymptote. So I am going to go ahead and create a table and see what happens as x approaches 2 from below. I'm going to start with 0. I plug in 0, I get negative 9 over negative 4. So that's 2.25. I'm going to plug in 1. I get negative 8 over negative 3, positive 2.67. These looks like they're getting bigger. Plug in 1.5, and here I resorted to the calculator. 3.82, 1.9. I get 13.82, 1.99, and I get 126.31. So we're going to follow that pattern. X approaches 2 from below of x squared minus 9 over x squared minus 4. We get infinity. So, gee, let's see if we could, come up with other ways to do this. So here we got the limit as x approaches negative 1. I cannot direct substitute that because that gives me a 0 in the bottom. But I can factor the numerator x minus 2x plus 1 over my x plus 1. The x plus 1's cancel. I get negative 1 minus 2, negative 3. H, again, we've got x approaching negative infinity. So I am going to focus on just the highest powers there. Limit as x approaches negative infinity, I got 12x to the third over x to the third. Simplify. I get 12. We want the limit of each part. I get the limit as x goes to 0 of x to the fourth times the limit as x goes to 0 of cosine of negative 2 over x. So the cosine part's going to give us an issue that is indeterminate. But take a look at the beginning part, the limit as x goes to 0 of x to the fourth, that's 0. So I got 0 times this second limit. Not sure what's going on there. And 0 times anything is 0. J, we are going to factor. And so it does not look like we have anything in common, numerator and denominator. But I got the square root of x minus 2. If I plug in 4 there, I get 0. And x squared minus 16, if I plug 4 in there, I get 0. So I'm going to factor this, x minus 4x plus 4. Okay, and then I'm going to look for that difference of square patterns. I've got the numerator, I've got square root of x. If I square that, I get x. And I have 2. If I square that, I get 4. So I'm going to factor this. Square root of x minus 2. X minus 4, I'm going to factor as square root of x minus 2. Square root of x plus 2. And I still have my x plus 4 over here. These cancel. I'm left with the 1 in the numerator. I can now direct substitute. I get 1 over square root of 4 plus 2 times 4 plus 4. Square root of 4 is 2, so that's 4 times 8. I get 1 over 32. Okay, I got the limit as x approaches negative 2 from below. And I'm dividing by 0 there. but I can't cancel with anything in the numerator. So I am going to go ahead and plug in numbers again, see if I can find a pattern. If I plug in, let's see, I need to go to the left of -2. So if I plug in -4, I get -8 times -1 in my numerator. So that's +8 over -2. I get -4. She says with authority. So let's plug in -3. If I plug in -3, I get -7 times 0 over -1, that's 0. -2.5. Well, here's how I'm going to look at this. -2.5 minus 4 gives me a negative number. -2.5 plus 3 gives me a positive number. And -2.5 plus 2 gives me a negative number. I get a negative over a negative. This is positive. So to the left of -2, that asymptote, my values are getting bigger. So this limit is going to infinity. L, can't plug in. -3. But let's look at what happens. So as x approaches -3 from the left, my numerator's positive and my denominator's positive. As x approaches -3 from the right, my numerator is negative and my denominator's positive. So here, that does not exist. The limit does not exist. Okay. M. I get the limit as x approaches 3. Notice that does not cause an issue in the numerator or the denominator. So I'm going to go ahead and direct substitute. Always try that first. Five times 9 is 45, plus 21 minus 12 gives me 54. 9 plus 9 is 18. 54 divided by 18 is 3. And I got the limit as x approaches 1. If I plug that into the denominator, I get a 0. So let's go ahead and see if we can factor and if that does us any good. X squared minus 3x plus 2 gives me the limit as x approaches 1 of 2 times what, x plus 2 times x minus 1. That's promising if I can get an x minus 1 in the denominator to cancel. And I have x minus 2, x minus 1. My x minus 1's cancel. Now I can direct substitute. I get 2 times 3, 6 in the numerator. Cram it in here. I get 1 times, let's see, 1 minus 2, -1. So I get a limit of -6. Oh, I want the limit as x approaches 4 from the positive side of the square root of 4 minus x. I can direct substitute. This function is defined to the right. And if I plug in 4, I get 0. P, though, as x approaches 4 from the left, this is not defined on the left, so that limit does not exist.